Hey, this is Pragya Shaha, and today I'm going to review another book on geochemistry. So, this is another very famous and interesting book, a book that deals with all the geochemical data. And whenever we talk about data, you will see another secret, dangerous weapon coming after it, and that is statistics. So, I will quickly go through the concepts, the contents. We have chapter 1 geochemical data, introduction, geological processes and their geochemical structures, processes which control the geochemical composition of igneous rocks, processes which control the chemical composition of sedimentary rocks, processes which control the chemical composition of metamorphic rocks, geological controls on geochemical data, analytical methods in geochemistry, X-ray fluorescence, inductively coupled plasma emission spectrometry, atomic absorption spectrophotometry, mass spectrometry, isotope dilution mass spectrometry, inductively coupled plasma emission mass spectrometry, that is ICP-MS, spark source mass spectrometry, electron microprobe analysis, ion microprobe, selecting an appropriate analytical technique, sources of error in geochemical analysis. Okay, here we have contamination, calibration, peak overlap, detecting errors in geochemical data, analyzing geochemical data, the introduction, averages, correlation coefficient, you see, statistics. Significance of correlation coefficient are assumptions in the calculation of product moment coefficient of correlation, Spearman rank correlation matrices, correlation coefficient patterns, regression, ordinary least square regression, reduced major axis regression, weighted least squares regression, robust regression, some problems with traditional approaches to correlation and regression, ratio correlation, an example of the improper use of ratio correlation, Pierce element ratio diagrams, application to trace element diagrams, ratio correlation in isotope geology, the constant sum problem, the consequences of closure, correlating compositional data, the means of compositional data sets, invalid escape routes, Aichi-san's solution to the constant sum effect. An example, basalt from Kilauea Lake, Hawaii, interpretation of log ratios, interpretation of trends on triangular diagrams. Then we have PCA, principal component analysis, discriminant analysis, an example from igneous petrology, other applications of discriminant analysis, withered geochemical data analysis, using major element data, introduction, rock classification, classifying igneous rocks using oxide plots, the total alkali silica diagram TAS, using TAS with volcanic rocks, a TAS diagram for plutonic rocks, discrimination between the alkaline and subalkaline rock series using TAS, the K2O versus SiO2 diagram for the subdivision of the subalkaline series, classifying igneous rocks using the cation norms, norm calculation and the oxidation state of iron, basalt classification using the nepheline diopside olivine hypersthene, okay, and quartz diagram of Thomson, granite classification using the albite anorthite orthoclase diagram of O'Connor, the QF anor diagram of Strickerson and Lemater, classifying igneous rocks using cations. This is actually a bit uncommon, you see, uncommon from the usual geochemistry book contents. We have a little bit separate things about norm. Classifying igneous rocks using cations, the R1 R2 diagram of De La Roche et al., the Jensen cation plot, the chemical classification of sedimentary rocks, arenite or wacke, mud rocks, discussion, variation diagrams, recognizing geochemical processes on a major element variation diagram, fractional crystallization, assimilation and fractional crystallization, partial melting, mixing lines in sedimentary rocks, the identification of former weathering conditions from sedimentary rocks, mixing and metamorphic rocks, element mobility, artificial trends, selecting a variation diagram, bivariate plots, Harker diagrams, bivariate plots using SiO2 along the x-axis, bivariate plots using which use MgO on the x-axis, bivariate plots using cations, bivariate plots using the magnesium number, triangular variation diagrams, the AFM diagram, problems in the use of the AFM diagram, interpreting trends on variation diagrams, extract calculations, addition subtraction diagrams, trends showing an inflection, scattered trends, a computer based approach to mixing calculations, modeling major element processes in igneous rocks, discussion, diagrams on which rock chemistry can be plotted together with experimentally determined phase boundaries, the normative albite orthoclase quartz diagram, the granite system. Here we have the water saturated equilibria, the presence of anorthite, silica undersaturated portion of the normative nepheline calcilite silica diagram, the nepheline cyanide system, petrogenesis residua system. Basaltic experimental systems, the CMAS diagrams projecting rock compositions into CMAS, interpreting CMAS diagrams based upon the Yoder Tilly CIPW normative tetrahedron, projections in the tholeite basalt tetrahedron, olivine, plagioclase dioxide, and quartz. The normative nepheline diopside olivine hyperstein quartz diagram, the low pressure tholeiitic basalt phase diagram, problems with CIPW normative projections, experimental systems for calcaline rocks, and with using trace elements. Now trace element data, this is a very interesting topic. Here you will get the trace element groupings in periodic table, trace element behavior in the magmatic systems, controls on the trace element distribution, okay, partition coefficient, measuring partition coefficients, physical control on the value of partition coefficients in mineral melt systems, okay, coefficients in kd value in basalt, basalt andesites, dacites and rhyolites. Then geological controls on the distribution of the trace elements, element mobility, partial melting, okay, contamination, crystal fractionation, rare earth elements, chemistry of RE, presenting RE data, interpreting RE patterns, normalized spider diagrams, PG plots. um then we have the selection of trace element in igneous rock or bivariate graphs, incompatible element plots, identification of igneous source characteristics. A very interesting topics. I mean, like the trace element, all the trace element data or information that you require is very well presented in this chapter 4. Trace elements chapter 4. Then we have the discriminating between tectonic elements, environments using geochemical data, discrimination of diagrams for rocks of granitic composition, clastic sediments, tectonic controls on magmatic and sedimentary geochemistry using radiogenic isotope data. Okay, here you have the Chur model, radiogenic isotopes, radiogenic isotopes of in petrogenesis, the role of different isotopic systems in radiogenic isotopes in petrogenesis, um, using stable isotope, radiogenic isotope, carbon isotopes, okay, all the isotopes are here. Yeah, and that is it. So it ends with the isotopes and all the isotope information that you need. It's a good book for geochemistry and focusing on the lab materials of the geochemistry. Hope you like it. Stay tuned for more videos. Until then, tata.